So the guys at ThinkCar recently sent us this. It's the ThinkTool Max, also known as the Platinum S20, depending on where you live in the world. Now, what's great about this tool is it comes with lots of accessories, and today we're going to take a look at the ThinkTool Scope Box. So the Scope Box is a 4-channel USB-based oscilloscope. It's got a 50 volts maximum input with a quoted 1 gigasamples per second sampling rate, which we'll get onto later. And from what I can tell, it's 8-bit. So what we're going to do is take a look at this today. We'll have a look what's in the box, and then we'll attach it up to some signals and take a look at all the features you get with this nice, convenient oscilloscope. So we get this box, which comes with the leads. Now, the leads that you get are okay to get started. We've got these BNC type banana leads, okay, like the stackable banana leads. However, they're not so long, which isn't a bad thing in some instances. If you want something a bit longer, just go out and get yourself some of these Hantek oscilloscope cables. So we get a few of those leads. We get lots of these crocodile clips or alligator clips. They're actually really nice quality and got a good strong grip on them, so yeah, no need to do anything with those. We get the USB cable, and we get a packet of back probes. Now, these back pinning probes seem okay to get started. They are quite rigid and not so thin, but they do come with these little replaceable pins there. So personally, you might want to go out and get something that's got a slightly thinner pin on there, just so you avoid damaging any connectors, but they will probably test most things. What we also get is 2 of these. These are the ×10 probes. So in here we've got a ×10 attenuator, which will allow us to measure voltages above 50, which I should point out, not suitable for high voltage electric vehicles. For that we would need a differential probe. But what these are also useful for are measuring systems that are very high frequency. So the oscilloscope itself then comes in this separate box here. And it's a nice size. We've got our 4 channels on the front there. And this here is for setting the compensation on these probes. So they basically have a little screw in the side of the connector there, and that will help set the compensation of the probe. So as far as I'm told, this is manufactured by Hantek, another popular oscilloscope manufacturer. You might have seen them with the 1008C. They do also make much higher spec, more expensive oscilloscopes than this, from which I imagine this shares internals with. Let's plug it in and give it a go. So we just plug this into the oscilloscope and the other end into the tool. So this is also available to use with the other ThinkTool diagnostic machines as well. Okay, so from the home page, what we want to do is slide up, and then we've got the oscilloscope app just there. And once it's loaded, what we can see is that we've got all 4 channels active. So we've got a yellow, blue, purple and green, and we can see that all those axes are alive there. So what we're going to do is focus on channel 1 first. So I'm going to turn off the other channels, and all we do to do that is click on the channel, click it again, and it turns it off. Same for the channel 3, the purple, and channel 4, the green. So now we've got channel 1 up here. What we can actually do is click to move that down. So literally just click and drag. It's quite easy to use. And there you can see we've got that now aligned, so 0 is in the middle. We can see at the minute that it's kind of flashing up and down. I am connected up to a crankshaft sensor signal at the minute, and we've only got 5 volts up the side there. So if we wanted to go up on the voltage, what we can do is just use these buttons here. So we can click there to make it bigger, or click there to make it smaller. Of course, we want to go smaller because we're going off the page at the minute. And now we can see that we've got this signal just flashing up and down there. Now what we need to do is change the time. So what we've got down here is the time setting just here. We can, if we want, click on there and select the time scale that we want. And if not, we can use the essentially the plus and minus buttons, and if we just keep clicking that one there, we will start to get our signal on the screen. Okay, so there we go, that's our crankshaft sensor signal there. I quite like how the plus and minus buttons are displayed in a way that we can relate to. So for example, we want to make the pattern smaller and bigger for the voltage here, or if we want to see more or less on the screen just down here. So what I'm going to do now is turn on channel 2, and that has got an injector signal activated, and we can see that there's part of it there, it is off the screen. What we have got is a maximum 50 volts input, so that should be good enough to pick up this whole injector signal. So we can see we've gone up to 40 volts there. What we've got is the rest of that signal is off the screen. So now you can see I'm trying to drag that channel 2 blue channel down, but it's not going. So what I need to do is go to the channel selection at the bottom where it says CH1, click onto CH2. Now when we click and drag on that, it's moving channel 2 down. Okay, and if we wanted to move channel 1 up, what you need to do is select channel 1, and now we can move channel 1 up. So it's moving around on the screen at the minute. One of the other basic settings that we want to adjust is the trigger. So if we just click on the trigger here, we can change that to channel 2, and what we will get is the trigger level is here. So if I just click back onto that screen, see this level? If you just click your finger in that area, it will move that trigger level up and down, and that is represented by this little arrow here. Okay, so you can see if we put the trigger level too low, we lose it. Okay, so get that trigger level in with your pattern, and then if we wanted to see the injector in a bit more detail, we could either reduce the time, okay, or if we wanted to just zoom into it, pause here. So if you hit that run, what we can actually do is then zoom into it while we're stopped, and then pan around the image like that. Okay. What we can also see is we've got this zoom feature up here. Now that allows us to zoom in on that complete buffer. Okay, so that there is basically what was recorded, and then if we want to zoom into that bit there, we can just zoom with these time settings down here and then move it using this kind of navigation bar at the top. So to get rid of that zoom menu, we can just click off it like that. Okay, what we have also got is some rulers. So if we wanted to measure the voltages, we click on there and we've got a ruler, and that result of that ruler is shown there. What you can see is that we only get the one ruler, and if I tap on it, can you see it lights up? So as you tap, it allows you to move it up and down. We've got another one down here as well, look, so we can actually do two, and you can see there that we've got the position of the two rulers and then the difference there represented by that little triangle. Okay, if we then click on channel 2, which I just did then, I just tapped it with my finger, you can see the rulers turned blue. Now when we move those rulers, we can apply them to channel 2 instead. So we do only got one set of rulers and they're shared between the two channels. We've then got here the vertical rulers, which will measure the time, and same again, if you click on it, you can just move it quite easily into place like that. Let's see what happens if we now reduce that time. So when you reduce the time back again, almost like zooming out, the rulers stay where they are, so you just have to move those back into position, which is quite easy to do. To get rid of the rulers, you just click on the cursor icons there to toggle them off. You can see we've got another one here, and that is our rotational rulers. So here you can set up the number of cylinders or the number of partitions. We would usually use this for things like in-cylinder pressure testing, so we can work out the 4-stroke cycle and the angle as well. So you might do 720 degrees if you were measuring a full 4-stroke cycle. So if we just click on OK there, what we can do is align that to this crankshaft revolution here. So some feedback I do have is that what we need for this is a degrees measurement. Okay, so when we put the rulers on here, we don't get a degree measurement up here, which is quite useful for doing things like crankshaft and camshaft correlation. So what we had a look at there was the basic features which you would need to get going and display any kind of waveform on the screen there. Some of the other advanced features that we've got here that are quite good is on the trigger we've got some advanced trigger options. So we've got a pulse width trigger, so we can actually trigger to a pulse width. I can actually demonstrate this to you now. So we've got the crankshaft signal up on the screen at the minute, and you'll notice that it's quite difficult to trigger to that and get it to stay still. Okay, all it will do is trigger to whichever line goes up. Okay, so it's, for example, it's on a rising trigger, so it's just trying to trigger to whichever one, and it doesn't know that there's a gap there. Okay, with the pulse width trigger, what it will do is look for that gap and hold it there. It's really good for timing chain slack diagnosis. So what we do is we select the channel that we want. I'm going to go for a pulse width which is greater than the time that we want to select, and if we now go on to that there, we can select the time, which is around about 2 milliseconds. It's not caught it at that. The other thing I tried was going negative, so if I change it to negative, we can see there now that it's actually found it. So what that might mean is that is a negative pulse. So what we are looking at is the waveform is on the negative side when it's capturing it. Okay, so that was what we did there to stop that from moving around, and so it could recognize it. So what you could do now is look at something else like a camshaft position sensor, which I've just put onto channel 2. Let's just make that a little bit bigger so we can see it. And what we would be looking for there would be the float between the crankshaft and the camshaft signal. Okay, so if they were moving, that would indicate that you'd got some slack timing chain movement. There's actually a video that we've already got demonstrating this on a BMW, so go and check it out. Same feature there then as what you get on a picoscope, which is really good. Some of the other advanced features that we've got in here is we've got the filters. So we've got a low pass filter. If you just watch this waveform here, you can see that it cleans it up quite a bit. Let's just zoom into that so we can see it in more detail. Turn off channel 2 for a moment. So we're looking at channel 1. If we turn off that filter, you can see that we get quite a noisy filter, and I think that's filtering at around 20 kilohertz or 30 kilohertz. I can't remember which one it is, but it's suitable for most automotive. High pass feature is not something that we would really use, to be honest, unless you were trying to look for certain interference in a signal that was high frequency, maybe on a CAN bus signal or something like that, but it's not one that I've used very often, to be honest. Also in here we've got the different probe options. So we've got the attenuator options if you were going to use a ×20 ×10 attenuator, and you might use them if you were going to do like piezo injectors, which are 200 volts. Remember, this is only a 50 volt maximum. Then we've got these different probes here. So we've got some ignition clips and coil on plug probes as well. We've also got some current probes here. So if you go on current, you can see that we've got some current probes there. What is also quite good is we can do AC coupling directly in the oscilloscope here. And another feature that I really like actually in Picoscope 7 is the very quick way to invert your waveform. So you might use this if you've connected an amp clamp and you've put it the wrong way around. You can just quickly invert it instead of using a math channel. About math channels, there are some math channels available on here. What I've done right now is I've just put on a CAN bus signal. It's only a simulated CAN bus signal from my waveform generator. What I'm going to do is change the trigger then back to channel 1 for a normal trigger, just a rising trigger there. So I've just noticed one thing you might have to be careful of is that trigger position. You can see that as we change the time, the trigger position moves. And actually I noticed this when using the Hantek, so this is something the Hantek suffers with, and I believe this is Hantek hardware. If we keep zooming in, look, the trigger's gone off the page over there. So what you need to do is try and keep that trigger in the middle. So we've got a point on there, look, up here, which shows us the trigger position. So now if we zoom in, that should pretty much stay on the screen. Okay, so there's our canvas image, and you can see there that we've got fair canvas image. We can make those both a little bit bigger so we can see it a bit better. And what we have also got in here then is the math channel. So some of the channels that I like to use on here are the channel 2, take away channel 1, which gives us then that perceived canvas message there on the screen. So basic math channels there, we can basically do our normal kind of plus, minus, times and divide. And then we've got some frequency functions here as well, which are not something that we really use much in automotive at the minute, but maybe be using them a bit more when we get into checking the operation of electric vehicle motors and things like that. So what we'd also got in here is the reference waveforms. So what we can do is click on here. You can see that these are the waveforms that I'd saved before. If you want to create your own reference waveform, all you need to do is hit the quick save down here. We've just saved that. Now when we go to reference and recall, we can see that we've got those extra waveforms displayed here. So we can actually recall 2 of those. And if we go back to our waveform, we can see now that we've got those reference waveforms saved there. So that's quite a nice feature to have. So if we just turn those off, those reference waveforms should stay there, and we should be able to zoom into them separately as well, which is quite good. So that is a nice feature to be able to zoom into the waveforms individually. And what we've also got there is some serial decoding. So if you're into serial decoding for CAN, we've got that feature there. Or you've got to tell it as which channel you're looking at, which CAN line you're looking at, or LIN, and then which speed that network is, and you can capture that as well. Okay, what we can have a look at is seeing how well we can zoom into this. So it's marketed as a 1 gigasample oscilloscope, and what we can see at the minute is we're currently sampling at 250 megasamples. That is going to be more than likely because we've got 2 channels selected. So when you select one of the other channels, the sample rate is shared. So let's have a look if we can get, so there we are. Now we've switched to 1 gigasample with 1 channel selected. Now what will happen with this is this is 1 gigasamples at this time scale, so it's relative sample rate. As we increase the time, so you watch when we go from 5 milliseconds to 10 milliseconds, we've halved the sample rate, okay? And then when we keep going up, the sample rate is reduced because we're now recording more information over a longer period of time. So let's just stop it there and see how it zooms into that. So it's still got quite a good message there, so that's pretty good, that is, to be fair. Let's really stress it out. So 500 milliseconds per division. Let's stop it there and see what we've got when we zoom in. Again, you know, pretty good, pretty good. Those lines here now you can see as they're going up in a more of a triangulated shape, that's where we're really stretching the sample rate. And that step feature, so if we just zoom into it there, you can see we've got kind of slight steps. That's because it's an 8-bit scope, so it's just the limited available steps to recreate a vertical image. But that's fine, most oscilloscopes are 8-bit, to be fair. Okay, so what we've also got is a single sequence there. So what that will do is literally, it's like a single trigger, if you like. It will just run the one sequence. So what we really want to do with that is go to a longer time base, something more human, okay? And if we do 1 second there, what we've got is single sequence. So I'm just on a variable voltage now, okay? I'm controlling that. Quite unusual as well, it's going from this side, which is not something that we usually see from an oscilloscope. If we hit single sequence, what we can do is record all that. You might use this for something like relative compression or taking pressure readings, and then it will stop it, so at least you can then come back to it, zoom in, and then, you know, check it out in more detail without having to worry about, you know, stopping the oscilloscope and losing the data. What we've also got is some automotive features. So the automotive features will just set up the oscilloscope settings for that type of sensor, so that's quite useful if you're not sure where to start. What we've also got up in the menu area is some measurements. So we've got duty cycle measurements. We should have some like average voltage measurements. So that'd be mean here, and then we've got like minimum, maximum, and frequency, which is also quite useful. What you've also got is this help feature here. So when you are connected to the internet, it will show you all the different features that you've got on there and explain them in case you weren't sure how to use them. So all in all, that's quite a nice little scope, and definitely quite convenient considering it is part of the tool. It means you haven't got to get your laptop out and things like that, and it will, you know, take a measurement on most things that you would want.